Hello and welcome to the Building Domain session as part of the buildingSMART International Standards Summit, Valencia 2024. Thank you for joining. My name is Sheila Karai-Lum and I will be your moderator today. Today's session is titled Smart Buildings. The speakers today are Alex Plenty, who is Senior Digital Construction Manager at Skanska, apologies, Sam Norledge, who is Digital Delivery Manager at ISG. This session is scheduled to last 90 minutes, which will include questions at the end. This session is being recorded and will be made available in the replay section of the event as soon as possible. On that note, before I hand over to speakers, I'd just like to remind you that this is a hybrid event. For the online attendees, your microphones will remain muted for the duration of this session. If you wish to make a comment or ask a question, please use the chat box in the control panel. And for those attendees here in the room, please try your best to keep the background noise to a minimum. And if you wish to make a comment or ask a question, please just raise your hand and we'll bring a microphone over to you. I would also like to bring to your attention that buildingSMART is committed to ensuring that participation in the development of standards is unrestricted and the process for their adoption is transparent. And standards that are developed do not favour any particular provider and are open, non-binding and accessible to all. So please take note of our antitrust code of conduct. And on that note, apologies for the delay, I'm going to hand over to Alex.
Thank you, Sheila. So my name is Alex Plenty and I'm from buildingSMART UK and Ireland. Recently, we've had two new members join our chapter in the buildings domain, and one of which is Sam, who's going to talk today. And Sam is an expert in smart buildings that make decisions. And what he's going to talk about today is some of the problems we've seen in the industry of asset owners and building owners not being able to use their IFC models in smart buildings platforms. And what we want to do is look at the issue, get your comments and feedback, and hopefully turn this into something we can fill in an activity proposal about, and this may be a future project, but we want your feedback and your thoughts. And without further ado, hopefully you heard all that, Sam, and you're good to go. I'll hand over to you.
I'm all good. Thank you, Alex. Can I just confirm everyone's seeing my screen, yeah?
Yes, we see it.
Oh, yep.
One moment, Sam.
Thank you very much. So good morning, everyone, and thanks for joining me today. Sorry I couldn't be there in person. I've had a knee injury, so I've been a bit incapacitated, so apologies for that. In this presentation, we're looking to examine some of the advantages and challenges of using IFC for integration with setting and smart buildings. Ultimately, what we really want to discuss is the potential project proposal for buildingSMART UK and Ireland to address these challenges and drive a change in this field. So, just a brief intro. Let me just introduce myself. I'm Sam Norledge. I'm a digital delivery manager at ISG. We're a global main contractor. My work involves managing the installations and commissioning of IoT solutions, along with the design and configuration of mechanical and electrical building management systems. I'm also well versed in BIM management and data assurance. My recent master's degree in building information management further solidifies my commitment to driving innovation in this field. I'm particularly interested in how we can leverage IFC standards to improve smart building integration. In fact, I've successfully applied my own methodologies on previous projects. So I'm getting a bit of feedback, is it? I'll just turn my volume down. Okay, so where we are with smart buildings. So why are we here today? There's the numbers speak for themselves. The smart building market is booming, and projections are reaching nearly 120 billion by 2032. This explosive growth signifies a clear mandate. Organizations like buildingSMART International must adapt and optimize standards like IFC to ensure that we can fully support and integrate this cutting-edge smart building technologies. Let's start with the key drivers to a smart building. So these key factors are what is fueling the market growth. So there's a growing urban populations. With cities becoming denser, smart buildings offer a sustainable solution for resource management. We've got facilities management savings. Smart building technologies are enabling predictive maintenance, streamlining operations, and even reducing costs for operations. And then we got energy conservation. So smart buildings, they would optimize energy usage, leading to significant environmental and financial benefits. And then finally, we've got occupant comfort that's driving this. Features like intelligent lighting, climate control, and CO2 monitoring are enhancing smart buildings. So what does a typical architecture look like of a smart building? So here's a simplified view of some of the typical systems we might see in smart buildings. We have everything from sensor monitoring, metering, and HVAC and access control systems. The challenge arises from the fact that these systems often come from different vendors, each with their own communication protocols and different data formats. The goal is to promote either open source solutions or at the very least enable systems to communicate via a central cloud broker, ensuring seamless machine-to-machine communication, data flow, and control. So current platforms scope. So it's important to understand the diverse stakeholders who are shaping the smart building landscape. And on the left, we have the building tenants and employees. These guys expect a convenient and comfortable spaces with intelligent room booking systems and features that cater for well-being like CO2 monitoring. In the middle, we have facilities management professionals. These guys seek solutions that streamline maintenance, identify faults proactively, and ensure optimal asset performance. And then finally, we've got the asset managers and building owners. These guys are driving the energy efficiency, data analytics, and data analytics that inform strategic decisions. And their overall goal is to increase the value of their asset as well. So as you can see, the smart building ecosystem encompasses users with distinct needs and priorities. This diversity is fueling the development of innovative tools that aim to address multiple aspects of building management. However, the true potential of these tools can only be unlocked with seamless machine-to-machine communications across all building systems. For smart buildings to reach their full potential, we need a robust and standardized data exchange protocol. So I'm just going to go down into the detail of what makes up a smart building. So this is an example topology of a sample smart building. I'll break down this topology piece by piece, and we can just dive into each section. So firstly, we'll focus on the edge layer. This is a specific entity layer. So this would be where individual components are communicating. This can include stuff like fan coil units, environmental sensors, lighting control systems. These systems all have their own native publishing formats, like BACnet for mechanical and Modbus, and DALI for lighting systems. IFC could potentially be improved at this layer to be more fully just describe these points, so these entities. And they can also develop relationships and enhancements to the entity descriptions. So we got the on-prem layer, on-premises layer. This is within a building. This is where we introduce key components like IoT gateways, responsible for managing the data flow between edge devices and the IT networks. Also, at this layer, there's a secure managed platform. Some people may refer to this as a single pane of glass interface or a SPOG. And this will be where everything's integrated into via one network controller. IFC could be enhanced at this layer by becoming like an IP data management process. For all these devices, we need to collect IP data during the delivery. So that would include all the patch numbers where it needs to go back to the network. All of that information needs to be collated, and that can be obtained from an IFC. And then you've got the single pane of glass enablement. So IFC could define how data is displayed in monitoring interfaces, potentially. And then we got the final layer, which is the cloud layer. This layer provides flexibility and scalability. Here we can route data into powerful brokering systems, connect to AI engines, analytics dashboards, and tenant-facing mobile applications. A key advantage is the potential to use a time series database, allowing this to retain historical data. And if we switch to cloud providers, that can come along too in the future. So IFC at this layer, of course, there's been a lot of developments with RDF models, like IFC owl ontology and building ontology topology. So these sort of graphical analytic tools that we could use could potentially be explored further and help this device enablement. And then again with MQTT, which is the publishing and subscribing protocol that we use in smart buildings. It's a low latency protocol, and it could potentially, there could be something that could be done there with IFCs. So the current challenges in smart buildings. So we've got disconnected process between systems integration and BIM. This disconnect can lead to limited interoperability and creates data silos, meaning that valuable data from the BIM isn't being shared effectively with the right people. So BIM managers on projects are not talking to the master systems integrators, meaning that there's probably, what I see is there's two schedules generated with the same information. Hardware moving faster than our data management processes. So the rapid development of smart building hardware means that our data management processes often struggle to keep up. This creates inefficient workflows and data bottlenecks, hindering our ability to leverage the technology that we've invested in. There's a lot of bespoke building management platforms, but no structured way to set these up. So many vendors rely on closed systems, making integration difficult and leading to vendor lock-in. Also, this creates a long setup time as nothing is standardized because it's all for each other's bespoke system. So no standard delivery methods for smart buildings, breaking down the golden thread. Without the established data processes, ensuring the integrity of the golden thread of building information, this becomes a significant challenge. Inconsistent documentation, fragmented workflows, and a lack of clarity around responsibilities hinder our ability to deliver truly intelligent buildings safely and efficiently. So industry in the UK have taken a proactive step to resolving this issue by developing the REBA Smart Building Overlay. This framework aligns smart building considerations directly within REBA Plan of Works. While this is currently focused very much on UK standards, this model demonstrates the growing recognition of the need for structured guidance and sets a precedent for other countries like who are likely adopt aligned to their own design and construction methodologies. The key challenge with this overlay addresses is the frequent disconnect between traditional construction workflows and the integration of smart building technologies. By embedding smart building considerations at each stage of the REBA plan of works, the overlay promotes early collaboration, which fosters essential discussions between all disciplines involved early doors, informed decisions, which ensures smart technologies and the choice of the technologies is aligned to the overall project goals. And then at the end, it does just enhance the successful delivery of projects. So it enhances the likelihood of on time, on budget completion of any smart building project. So it's a good step, but it's just the first. So why are we here talking about IFC? So IFC and smart buildings, I think they go hand in hand. I'm just going to go through a few demonstrations of why that is. Well, IFC, it provides a solid foundation for delivering and operating these complex systems. Think of it as an established and secure central repository for all device information. This breaks down the silos and ensures compatibility regardless of system origin. IFC is aligned to key ISO standards, which further reinforces the value and as a trusted data management platform solution. Additionally, IFC empowers to establish a robust validation process, both standardized processes and custom ones as needed. This validation leverages official IFC schema and also the emerging IDS, the Information Delivery Specification. This can be tailored to rules for your specific project and needs. So while IFC offers significant advantages for smart building implementation, recognizing certain challenges is crucial. Firstly, there's a lack of standard methodologies for leveraging IFC in smart buildings. Even with best efforts, current IFC capabilities might not be granular enough to capture the nuances of complex smart systems. Furthermore, I think it's essential that we define the optimal boundaries of IFC usage, the points at which it's best to integrate with more specialized system tools and smart building platforms. We need to know where that line sits. And finally, there is the need to develop standardized contractual requirements and specifications for IFC embedded smart building deliveries. So the metadata problem in the world of smart buildings, there are several metadata ontologies aimed at structuring data and capturing relationships between devices. Today, we'll focus on one of the most popular, which is the BRIC ontology. BRIC offers a standardized language for describing building systems and their components. It defines not only the types of equipment, but also the critical data points associated within them, such as temperature set points, airflow, and various sensor readings. To illustrate, let's visualize how BRIC would model the integration between an air handling unit and a variable air volume box on a specific floor, in a specific zone in a building. So here we have the air handling unit with its child element. So it's a parent-child relationship between the air handling unit and its supply fans within that unit and cooling cores. These cooling cores are fed from different risers in a return and supply loop, and the supply fans are fed by air towers. this AHU would be feeding information, feeding VAV in a certain zone and a certain space and a certain room in a building. And that relationship is built up via this brick model. Now, these are the data points from that VAV. So this is what that VAV is communicating, or it's being fed back to that VAV. And that's damper positions. So that will be the set point of where the damper sits. The supply air temperature sensors. So that will be the airflow sensors and all the sensors within that room or in that piece of duct. And then we've got the airflow set point. So that will be manually or automatic air set point. So depending on what the settings are in the room, that will be how it's defined. Now, mapping this up to IFC isn't the most difficult. Like we've got these pieces of equipment. So we've got air handlers, we've got IFC fans, we've got coils, we've got distribution systems, IFC systems, we've got air terminal boxes, and we've got spaces and zones and boundaries. But another key element as well with the smart building space is getting those X, Y, Z coordinates from the IFC. That could be critical to setting up devices, ensuring that they're communicating in the right place and right area. If there is no spaces defined or zones have not been are going to be changed later on, that can be done as well. Where we don't have information in IFCs is these points. So a data point is basically just something an input basically, and it's not a physical entity. With IFC, everything is kind of represented as a physical entity or a physical set of data, whereas set points and adjustments or points, they're just not they're not part of what an IFC should look like. So if you look at this AHU again, you can see it's got various different point names for one piece of equipment. So that's a fundamental problem. We don't have those mappings that can represent that in a more efficient way. Points are just, yeah, they're not physical entities. We can see buildingSMART have made a move with IFC4 with defining an IFC sensor, which is great. And we've got various types of sensors, which is really, really useful. So there has been movements in this era. And I think we have the foundation to build off. And then also another consideration, this must be, I just have to mention this because it's very, very important, and it's about having a universal device naming standard. So in the UK, we've got the building device naming standards with the BDNS. In other countries, there's others, but really this is so we can tag elements with the correct tag. So an AHU is called an AHU, not anything else. But yeah, this is so that we can define more semantic relationships with devices, and if that's in the IFC, then we could build this sort of information. But that is one thing that needs to be there. And at the heart of any IoT deployment lies a robust validation process. Without ensuring that data is accurate, complete, and properly formatted, any smart building system will fail. Imagine the power of tapping into the existing works of IFC validation that we've already developed over all these years. These tools can offer valuable starting point for us to ensure data integrity in smart buildings. There's also a massive potential in merging open source software validators that are being used in smart buildings today, such as the Universal Device Management Interface, the UDMI, and those MQTT publishing subscribing system that we can use some of the validation tools that are available on their GitHub, and integrate those tools into IFC, so the validation can be done direct in IFC. So this would create a powerful toolkit for ensuring that everything from sensors and controllers to exchange and commissioning as well would be fully validated. Yeah, so that's a really important point, that validation is key to any smart building. So IFC to brick. So these next slides, I'm going to go through some of the research produced by UCL. The guys that were involved in this were Demetrios Mavrokonidis, Kyriakos Katsigaris, and Demetrios Rovas. These guys have generated papers based on this, and they've done a lot of research. And we're currently engaging with UCL on this. So where we are today, so this is where their research starts. So a significant study in 2022, which is very recent, by the International Energy Agency. It offered valuable insights into the role of IFC in smart buildings. While acknowledging that IFC isn't the sole solution, the study kind of highlighted that a specific strength of IFC, and that's that it excels in semantic tagging and providing robust data structures. However, the key area for improvement lies in the limited data capabilities, linked data, so like the RDF models. This means that IFC might struggle with creating rich interconnected relationships like what we were just discussing, like schemas like brick and real estate core can do. So it's that relationship that they're lacking. So further research into brick and IFC mappings has been carried out. This research suggested that IFC models have the potential to include data elements valuable for brick. In theory, they found that 4.5% of IFC data could be mapped to brick. However, the reality is less promising. When examined actual IFC models from 20 sample buildings, only 0.2% of the data readily mapped to brick. This is a significant gap, and it indicates that current usage of IFC might not be optimized for smart buildings. So this solution through Link Building Data. Link Building Data is a buildingSMART group. It unites experts in BIM and web of data to unlock the power of linked data across buildings' entire life cycle. They define specific ways linked building data can streamline our workflows. So this benefits both the private sector and the governmental organizations that rely on data from BIM and sensors and more. By making this data work together seamlessly, we can make smarter decisions at every point. So one of their initiatives is the building ontology topology, or BOT for short. Think of this as a way to simplify how we describe physical structure of buildings and smart applications. BOT focuses on the core components like floors, spaces, flow systems, and things within them. One of its key strengths is the ability to integrate seamlessly with other systems. This might include product data catalogs, they're completely full of specifications, live sensing data, and even IoT device information. By combining these data sources, BOT helps achieve the advanced collaboration and data management processes that we need. However, at this time, the use of BOT with IFC is not seamless. And on the next few slides, we'll just cover some of this. So here we can see the process of utilizing IFC information with an ETL tool, which is extract transform load, to generate the TTL RDF model, which is the brick model, or any others. This process could be streamlined and improved. For instance, the mappings could be refined, or buildingSMART could develop a specialized ETL tool to standardize this process. But this hasn't been done. So here again, we see the knowledge graph. It starts with extracting that building information from the IFC, linking it to bots and other relevant ontologies, then using a semantic rule engine to transform the data, ultimately producing a brick TTL file. It's important to note that this process is currently one way. This could potentially cause issues when it comes down to building retrofits, renovations, and there's no established path for updating the original IFC model based on characteristics reflected in the knowledge graph. Here again, you can see demonstrated workflow, the need for that ETL tool and the data mappings to produce this output. So the key is really those accurate mappings, and not all of that has been done yet. So let's talk about the project. Ultimately, I'm here to talk about a potential project for buildingSMART, specifically buildingSMART UK and Ireland. We're going to focus on with the buildings domain. So the project itself. So this is the brief aim. I've tried to get this simple. It could get very overcomplicated and convoluted. So the real aim is just to bring together smart building metadata standards like Brick, like Haystack, like the digital twin definition language, or others. There's lots out there. And IFC to generate a more efficient way to deliver smart buildings via improvements to the IFC 4.3 schema. So the outputs and the objectives of this is we want to start mapping ontologies with IFC 4.3. Now, we've already started doing some of this in the Haystack working group. Project Haystack is just another metadata ontology, but it's more of a tagging methodology. And we've already carried out a lot of that mapping in Haystack. We want to review and suggest improvements to the IFC schema via a white paper. So, of course, the output of this is going to end with some suggestions and suggest improvements to Haystack and Brick. So we're not just trying to improve IFC here. We want to improve all of the ontologies, and we're not trying to create a new ontology. We just want to improve ones that are already existing. And we can do that via because they're open standards and they're all available on GitHub. So again, must emphasize the use of standard naming principles from the industry, because I still think that we're not quite there with standard naming. There's a lot of efforts out there, but there needs to be one now that is just defined. And then deliver methodology on a live IoT architecture. So we would want to produce this on a live project. And then this is the timeline. So yeah, we've got industry experts from all these different ontologies and different sectors. And yeah, so we've gathered these experts, and we've had numerous sessions with them, and that's what we wanted to do before we had this presentation today. So we're proposing the project today at the buildingSMART Summit. And phase 2 would be the framework deployment. So this would be, we would want to discuss potential sponsors. We want to get that sort of ironed out by July 2024. And then we want to map data ontologies. Like I said, we've already started some of that, but there is more work to be done. And then present issues for and against each ontology and improvements to IFC4. That's kind of how we're going to start writing this white paper. And then begin the findings and present them by December 24. And then the live project deployment will start in 2025. So I've had a chat with quite a lot of industry experts, and a lot of the controls companies are very interested in what we're doing, and I'm sure we would be looking to get sponsors from these sort of guys, but it's not limited to that. It's just that these guys will show a particular interest because it would improve their workflows and basically help them deliver jobs more efficiently and better, more validated. So benefits the industry. So buildingSMART, I've created this like proportional area graph based on the project's potential impact according to some of the buildingSMART initiatives. I believe this project will influence areas, but I anticipate the biggest area is going to be the digital twins and smart building design and contracts. And then also, like I mentioned, the information delivery specification. I think these can fall in hand. Additionally, it could contribute to the concept of operational material passports and further the excellent work being done on buildingSMART data dictionaries. These are just some of the many smart building software vendors on the market. So this sector is rapidly growing with more and more companies relying on IFC data for seamless integration. You've probably seen it before. There's all of these platforms. They all have like an interface with a BIM model of some sort, and usually it's IFC. So buildingSMART must really stay ahead of this curve and actively engage with businesses like this to ensure like continual success of IFC, and also improve the ingestion into these platforms. Okay, so I think I've come to the end of the presentation now, but we've covered a lot. I'm looking forward to the questions, but I'll just say the key takeaway is that IFC isn't about technical compatibility. It's the foundation for a better, smarter built environment. Imagine a future where buildings and energy are energy efficient, responsive to occupants' needs, and adaptable to changing technologies. A future where data moves seamlessly to support sustainable goals, ethical practices, and long-term asset value. This vision is within reach by advocating for continued development of IFC, by actively participating in the buildingSMART community. We can shape the future. Our work is essentially not only for streamlining our industry, but also for ensuring the buildings we create tomorrow serve both people and the planet. Gracias, and thank you to buildingSMART Spain for hosting this. Yeah, I'm ready for your questions.
Do you want to come over here and ask your question? Is your microphone on? Actually, Bob, you can go over to the lectern, that works. Oh, well. So you don't have to crouch down.
Now I'm here. Choice. Yeah? Hey, thanks for an excellent presentation. This looks a little bit like an UK and Ireland activity. How can we scale this up internationally? Do you have any ideas about it?
So I feel like we should be scaling this up. It would be great to. We've already actively engaged with buildingSMART Japan over this, and potentially some others. I've seen numerous presentations in the past based on this. And anyone that wants to get involved, please reach out, because I'm more than open to get this conversation going. It'd be great.
Yeah, I think that's why we're here, really. So, you know, we've spoken about it in the UK. Sam's experience is very UK centric, but we want to make it much bigger than that. So, you know, a lot of the organisations Sam referenced are all sort of international, especially a lot of those companies at the end, and that's what we don't want it to go down a rabbit hole of just UK centric. We want to sort of look and see what we can do a bit bigger than that, and that's what we want the goal to be. And we're at very early stages, really, and you know, the next step from this would be filling an activity proposal, and we're very open to what those outputs would be. So whether it's you know, mappings and endorsements of those, changes in the schema, IDS files, all of that is sort of open really for that, and that can be guided by, you know, anyone's experience from any other countries.
So you can hear me?
Yeah.
Yeah. Hi, I'm Jürgen. I'm an architect, and I didn't get all the details that you were just presenting. But one thing that comes into my mind as an architect is you showed us that you transfer all the information from the IFC model to your brick world, whatever it is. What I'm interested in is it also possible to get all these informations back into the IFC file? Because you know, I'm talking about the digital twin, and as an architect, I would like to have most information back in my IFC model, or the MSC people want to have it as all those informations back. Is that also a kind of an issue you have?
Yeah, so that's a great question. That's one of my slides where we should stop with IFC, and it seems when we're trying to create some of these really complex metadata models, ontologies, there needs to be a point where we decide, like with the point names, we don't need to go to that level in IFC. I don't think that's necessary. We can still visualize it in a digital twin, but there is no, I wouldn't say that that's necessarily the level that we need to go down to. And that, when you map brick back to IFC, I imagine that's where the usefulness would decrease.
I think one of the purposes of using IFC would be if you're using a certain platform for your smart building, how free are you then to chuck it on something else? You know, how interoperable is that? And in terms of what data would be transferred, exactly what Sam said is like, where do you stop? So if in a smart building, you'd have your asset model, and then you'd have lots of sensors, and they would be getting live telemetry data for how hot this room is right now, or, you know, how fast the fans are whirring, that sort of thing. And that live data, you wouldn't necessarily need to transfer that across, and that wouldn't necessarily be stored in a file to be chucked in something. But the bit that Sam was talking about, where if you're sticking sensors on things and you're building up that architecture of how they all fit together, how much of that do we keep in an IFC file to then transfer onto another system? So, you know, the live data might not need to go across to another system because it's always generating more data. But how much of the sort of architecture of the system will be all interoperable enough that you could plug it into a different platform, you know, when business needs change, or whether the software is too expensive, or whatever the need would be.
Hey, Alex, is it specifically a brick that you're looking at, or real estate core for Microsoft?
Yeah, bigger. I guess, correct me if I'm wrong, Sam, probably a bit bigger than necessarily just brick. I think brick in the UK is probably one of the most used smart building schemas at the moment. Yeah. And they've probably done the most work of comparing that to IOC, as Sam gave the sort of 4% mapping, that sort of thing.
Microsoft is investing millions in real estate core. Have you heard about that?
Yep. Yeah. So I think we want to channel any of that to make sure it's all is interoperable, right? So it's the same is in the buildings industry, where a lot of BIM software sort of went on its own road, and now we're trying to get it onto the same sort of tracks and then talking the same language. But we kind of want to tackle it early enough that people are producing software and they're investing in something that is going to be interoperable. We really want to get in before too much progress is made and too much maturity is in the industry.
Well, you have your support now from the Netherlands. Yeah, absolutely. We are diving into this.
Also, can I mention that we don't want to do. Yeah, it's not going to be specifically focused on brick. Definitely not. But we also don't want to do our own ontology. Like that's not a solution for us. The link building data group, they're focused on that, and that's what they do. And there's no need for another one of those. We can use what they do, and it helps enable our work. But we really want to help with the mappings and just create something a bit more easier for project delivery and handover.
Yeah. Okay. I don't think we've got any questions online either.
Let's just have a look.
Okay.
No,
cool.
we don't.
Must have been very agreeable, Sam. Everything you said. It's not prompted any discourse. Nobody's got angry here or whatever. So very amenable presentation. I guess you had your contact details on the slide, and people can get in touch as well if they've got any questions. And the next steps for us will probably be producing this activity proposal, and there's sort of more formal questions and comments at that stage anyway. But yeah, thank you very much, Sam, for your presentation, and thank you all for your time. And I think we can probably call it that.
Absolutely.
Thank you very much. Thank you, guys.